Yay. Okay, cool. All right, so we're gonna go over the 24 multiple choice questions again. This is the Regents exam you all saw last June. Um, so these questions should look familiar. If you have a specific question, drop it in the chat and I'm happy to answer that. So I should be able to get through all these. If not, I'll continue going and you can, watch the video back or you can stay on. So the perimeter of a triangle is 18. What is the perimeter of a triangle after similar triangle after dilation of scale factor of 3? So what I would suggest is just kind of sketch, a triangle. And if it has to have a perimeter of 18, you could just make up some sides, right? You could do like, I don't know, 10, 2, and 6, something like that, right? That would have a perimeter of 18. And then if we're going to dilate this thing by a scale factor of 3, I'm going to just draw a bigger triangle. Whoops, not like that. And so scale factor of 3, that means the side lengths would be, well, 2 times 3 is 6. 6 times 3 is 18. And 10 times 3 is 30. So what do those add up to? Well, 30 plus 18 plus 6 is 54. Yeah, not too bad. Okay. Any questions about number 1? All right, we'll keep on trucking then. Here we go. The Washington Monument shown below is in Washington, D.C. They use such a precise angle that I wonder if this is actually an accurate measurement. But anyway, it seems weird. Washington Monument shown below is in Washington, D.C. And at a point on the ground, 200 feet from the center of the base of the monument, the angle of elevation to the top of the monument is 70.19. What is the height of the monument to the nearest foot? So this is a trig question. So they gave us this angle here. This is my reference angle, right? So some person was standing down here with some device to measure the angle of elevation, and they were 200 feet away. And we're trying to find the height. The height is our opposite side. This is our adjacent side. So, Toa. Some old horse came a hopping through our alley. So we know the adjacent side and we're looking for the opposite side. The hypotenuse has nothing to do with this problem, so we're going to use tangent. So the tangent of 70.919 whoops, what's happening? Oh, somebody else is there. Okay, sorry. Back to the problem. I'm just trying to find my calculator. Okay, tangent of 70.19 equals the opposite side, which is x, over 200, which is our adjacent side. Opposite over adjacent. So I'm just going to set this over 1 and do a little cross multiplication. And you're going to get 200 times the tangent of 70.19 equals x times 1, or just x. So let's go ahead and bring up our calculator. So 200 times tangent of 70.19. 555 feet. That's pretty tall. And that's correct. 555 feet. I guess it is pretty tall. That's like, I don't know. How tall is the high school? Probably 100 feet. So it's like five of those. Okay. Um, no questions yet? Okay. We're going to keep going. On the set of axes below, EQA and SUL are graphed triangles. Which sequence of transformations shows that triangle EQA is congruent to triangle SUL? Okay, this is a very good example of everything I've been preaching in class for the last, well, when I was your teacher for all of y'all that had me. The first thing I said, if you see a transformation question, is go ahead and draw in these arrows to show the orientation, meaning is it clockwise or counterclockwise of the points? So E to Q to A and then S to U to L. Notice they're going the same way. So this is clockwise. This is also clockwise. So if they're both going the same way, then that means it can't be an odd number of reflections. So I don't need to do anything else with this problem, and here's why. It can be two reflections, right? Because the reason, like, think about like letters on your shirt when you look in the mirror, they're flipped around. If you're in a double mirror, like if you're at like a, hair salon or something like that, you get flipped back, you have two mirrors, like one in front, one back, but letters go back to normal. But anyway, um, look at these answer choices, and I'm just going to circle the words, or even I'm just going to highlight the words reflection. So there's a reflection. There's a reflection. Here's a reflection. Notice that three of these answer choices have just one reflection in them. It can't be any of those. It has to be this one. I don't need to do anything else. I'm done. That's your answer. Because it's a rotation and a translation. It has to be that one. It cannot be any of the others. So that is so easy if you just do that one little trick of putting in the arrows and determining whether they're going the same way or the opposite ways. Okay. All right, moving on. When I saw that question in June, I was like, yes, so easy. Okay. If two sides of a triangle have the lengths of 2 and 8, the length of the third side could be, well, we have a little triangle inequality theorem here. So the two shorter sides have to be longer than the third. So in this case, like what is 2 plus 8? Is that greater than 10? No, that's equal to 10. So it can't be that one. Now the two shorter sides in this case would be 2 plus 7. Is that greater than 8? Yes, it is. There's your answer. Let's check the other ones. 2 plus 6, that equals 8. Can't be that one. 2 plus 4 is less than 8. Can't be that one. It has to be greater than 8. Oh, greater than the third, the longest side. So the two shorter sides, add up the two shorter sides, they have to be longer than the third. So the first four problems I thought were pretty straightforward. Okay, a regular octagon is rotated about its center. Which angle measure will carry the octagon onto itself? I'm just going to go ahead and copy the diagram from my solution guide that I posted on Classroom. This amazing solution guide, all these fun notes here. So I don't want to have to redraw that. So if you look at this diagram, so here's an octagon. An octagon will be onto itself every 45 degrees, right? Because if you think about 360 divided by the number of sides, that's going to be 45. So each one of these little slices here is 45 degrees. So two of those slices would be 90 degrees. So it will be onto itself if it's rotated any number of 45s. So 45, 90, 135. Wait, does that add up? Yeah. 180, 225, 270, I think. Yeah. Anyway, you get my point. 315 and 360. So any multiple of 45 would carry that onto itself, meaning each of those slices, those triangles would map onto the other one. Okay. Oh yeah, circle equation. All right, got to do a little completing the square. They're probably going to ask you one circle equation like this. So it's good to know how to complete the square. So I'm going to go ahead and group my x's together, x squared minus 6x. And I'm going to group my y's together, plus y squared plus 2y. And that's all going to equal 14. So what you do is you take that middle term, you divide it by 2, and then square it and add that to both sides. So -6 divided by 2 is -3. -3 squared is 9. Add that to both sides. Same here with this one. What is 2 divided by 2? That's 1. 1 squared is 1. Add that to both sides. Now, I'm able to eliminate 2 answer choices. Here's why. Because notice this all equals 24. So the radius has to be radical 24. So it's not either of these two. So I've already got it to a 50-50 chance. Now I just have to figure out which one it is. So if I factor these two things, so this would be x minus 3 squared. If I factor that, and this would be y plus 1 squared. So which of these is it going to be? This one. Because it's x minus h squared plus y minus k squared equals radius squared. That is your circle equation. And this is the center. The h and k. Check out my circle equation completing the square video if you need help with that. Okay. Oh, I thought this problem was pretty cool actually. Because it's just a straightforward trig question where they're just asking, so what is the measure of this angle here? And we know this is the only thing that was a little weird is the way they drew the right triangle. So remember, like this is like an arrow pointing to the hypotenuse. This would be my adjacent side. So that's the one thing you have to be careful with. And here's my opposite side. So Katoa. Whoops. Some old horse came a hopping through my alley. All right. So we don't care about the opposite side, right? Because that's not part of the problem. So it's not going to be sine or tangent. It has to be cosine. So it's going to be the inverse function since we're looking for the angle. So it's going to be x equals the inverse cosine of the adjacent side over the hypotenuse. Plug that into our calculators. Second cosine, 23 divided by 30. No questions? No questions yet. All right. There's your answer, 40. What am I doing? I get that right? Looks like it. Oh, I forgot to circle this one. 5 was 2. Um, okay, here we go. This is a cool problem. It's a little tricky, but if we use just a little bit of kind of like intuition here, doesn't it look like all of these triangles are the same length? Well, I know these problems are not drawn to scale, but they are all the same. So all of these triangles are actually the same measure because why? Because they told us that these things are mid-segments. And what is a mid-segment? It's basically dividing the line segment into two. So um, CA is 14. That means each of these needs to be 7. CB is 20. That means each of these need to be 10. And FB is 9. So that means this thing needs to be 9 as well. And what am I looking for? I'm looking for the perimeter of quadrilateral DEFA. So D to E to F to A. I want this perimeter. So I know 2 of the sides already. So since all of these triangles are the same, and the reason being is because they're all congruent. We could go through a proof as to why, but we don't have to. Um, it's because of these are all mid segments, and so they're all being cut in half. So if this is 9, this also has to be 9. And then this is going to be 7. So, and then, this would be 10. We don't really need that because they're all the same triangle. So what's the perimeter of this thing? Is going to be 7 plus 9 plus 7 plus 9. 32. I didn't think that one was too bad. Okay, moving on, a little 3D geometry. A candle, let's use a different color, blue. A candle can be modeled by a pyramid with a square base as shown below. The height of the candle is 10, and each side of the base measures 6. If candle wax burns at a rate of 3.5 cubic centimeters per hour, what is the approximate number of hours the candle could burn? All right, well, the first thing you need to find, if you see a 3D geometry question, odds are you have to find the volume. The volume of a pyramid is 1/3 area of base times height. What is the area of the base? In this case, this thing is a square, so it's 6 squared, or 36. Okay, so the volume is going to be 1/3 area of the base, 36, times the height of 10. Well, what is 1/3 of 36? That's 12. 12 times 10 is 120. 120 cubic centimeters. I was shocked that they didn't actually have that as one of the answer choices. Usually they do that, right, to try and trick you. So shout out to the Regents people for not trying to trick you on this one. So clearly I need to do more work. What do I need to do? Well, it's 120 cubic centimeters, and I know it's going to burn at 3.5 cubic centimeters per hour. So I just need to divide this by 3.5, and that's going to give me the number of hours. So 120. And if you just look at all the answer choices are smaller than 120, right? So it leads me to believe that I should divide this thing. So 120 divided by 3.5, what does that equal? Let's try it out. 120 divided by 3.5 is 34.28. There's our answer, 34. Cooking, doing well. Definitely going to finish in the hour allotted. Okay. All right. Circle part problems. So once again, if you go to classroom and take a look at all of these amazing study materials that I posted on here, we got this circle reference sheet on here, which has pretty much everything you possibly want to know about circles. Um, what is this one? This problem here is, oh, we have to find the angle. Oh, sorry. Yeah, we have to find the measure of angle S. So let me show you what fact that is here. That's going to be this floating angle over here. So x equals z minus y over 2. So let's go ahead and take a look at that. So they told us that we have a tangent, which is this thing, and we have a secant, which is this thing. And they told us that arcs TU and RU are equal to each other, and then this arc TR here is 68 degrees. So the remaining bit, so this piece here, and this piece here, so the arcs of a circle have to add up to 360. Those two are equal to each other. So what is 360 minus 68? I don't know, I can't do that in my head. That's 292. So those two arcs combined, these two arcs combined have to equal 292. So these two. Okay, but they're also equal to each other. So what's 292 divided by 2? 146. So each of these arcs here are 146 degrees. So the angle on the outside, this outside angle here, call that x, is going to equal the difference of those arcs divided by 2. So x is going to equal 146 minus 68 over 2. That's, again, right here in this reference sheet down here. Okay. Plug that into your calculator. 146 minus 68. That equals 78 divided by 2, 39. No questions. All right. I'll keep on cooking then. Triangle RST has the measure of angle S of 33 and RS is 7 and ST is 12. You will definitely get a question like this. This is the side angle side trig area formula. So here, this angle here is 33 degrees. This is S. RS is 7. And ST is 12. So this is the side angle side trig formula. So the area of the triangle is going to be 1/2. It's always going to be sine of the angle times the two sides. You're probably wondering why that works. Maybe you're not. I don't know. The reason that works is because what you're really finding here is the height. Because the sine, this would be the opposite side, right? And this would be the hypotenuse of this little right triangle. So this, you're really just using trig to find the height of the triangle, and then its area is 1/2 base times height. So that's why it works. But you could also do that. You could go through that whole process of finding the height using trigonometry, and then using that in the area of a triangle formula. So what is, okay, so 1/2 sine 33 times 7 times 12. 22.9. There's your answer. No questions about that? Okay. Oh, this was a weird question. So this is actually new in the curriculum, like these. Anyway, so basically what I would do is graph this thing. So A is -3, -2. And where's A prime going? A prime is going to be -6, -2. So this is where A prime is. B prime is going to be at -2, 2. And C prime is going to be at 8, 1, which is all the way over here. So what does this new triangle look like? So I don't know why they are doing these types of questions now. It's definitely new. Um, so it's not a dilation. So if you just like look at this thing, like how is this being stretched? It's being stretched horizontally. So it's being like kind of stretched out in a horizontal fashion. So it's not really a dilation because a dilation would actually stretch it both vertically and horizontally. It's definitely not a translation. And a vertical stretch would kind of stretch it like this way. That would be vertical stretch. So if you just kind of see like the everything's kind of being stretched out this way. Okay. No questions. All right. Which equation represents a line parallel, important, to the line represented by the equation y equals 4x plus 6 passing through the point -3, 2? So the first thing you need to do is think about the slope. So the slope in this case is 4 over 1 or 4. So a parallel slope is going to have the same slope. So these are all in point slope form. So these are the slopes. So it can't be this one or this one. It can't be 3 or 4. So once you identify that, what is the slope? Is it parallel? Great. These would be perpendicular. So if it said perpendicular, it would be one of these, but they said parallel. Okay. Next thing, once you've identified the slope and figured out which ones it's going to be, what you can do is just plug in the point into the equations and see which one works. So I'm going to plug in the x coordinate and the y coordinate and see which one actually works. So the y is 2 and the x is -3. So it would be 2, -3. 2 minus 2, does that equal 4 times -3 plus 3? Yeah. So it's number 1. Okay. Which two-dimensional figure is always formed when a plane intersects a right cylinder perpendicular to its base? Well, let's just sketch a right cylinder. You don't have to do this, but kind of helps me visualize the problem. Okay. We have a cylinder, and I'm going to cut this thing perpendicular to its base. So just imagine if I'm just slicing this thing kind of like this. What's that shape going to be? A rectangle. If it was parallel to the base, it would be a circle. Triangle KMP drawn below. CE is drawn parallel to MP. This is a similar triangle question. They love these. Again, what do I always do for these problems? Triangle KMP is similar to triangle KCE. How do I know? Well, because they told us these are parallel, then that means that these angles are congruent, and these angles are congruent because they're congruent corresponding angles. That angle is congruent to itself. So it has to be a dilation, angle-angle similarity. There you go. So I'm going to go ahead and figure out my fractions, Km over Kc. I haven't even labeled the diagram yet. I'm just going to go ahead and set this up first so I know I won't make any mistakes. Kp over Ke. So it was the first two over the first two, the last two over the last two, the first and last over the first and last. And that gives me my fractions. So Kc is 8, Cm is 3. So that means that this whole distance is 11, 8 plus 3. And they told me that CE is 12. And what is the length of MP? So let's go ahead and plug everything in. So Km is 11, Kc is 8, MP is X, and CE is 12. I don't need this. That's not part of the problem. Now, just do a little cross multiplication, or you could use scale factor, right? This 11 over 8 is the scale factor. It's how many times bigger this bigger triangle is than the smaller triangle. You do it that way. I'm just going to go ahead and do a little cross multiplication. 11 times 12, that's 132, equals 8x. Divide by 8. 132 divided by 8, I believe, is 16.5. All right. If you see a question where it's asking you about a rectangle, go ahead and sketch the rectangle. So a parallelogram must be a rectangle if its diagonals are. Well, let's go ahead and sketch the rectangle first. And we're going to go ahead and sketch in the diagonals because it's asking me about the diagonals. So are they perpendicular to each other? Do they intersect and form a right angle? No. So it's not that. Do they bisect the angles? That means that this would have to be equal to that. That's not true. It's not that one. They do bisect each other, meaning they cut each other in half, but that's true for all parallelograms. What's the particular fact about diagonals of a rectangle is they're actually the same length. So that's what's so number two is also true, but it doesn't have to be a rectangle. So that's the key word there. Must be a rectangle. So this could be a parallelogram. Meaning it could be something like that. Okay. 20 minutes left and 8 questions. Oh my God. Okay. All right. For these questions, these directed line segment questions, I always just focus on the x coordinates because it's easier for me to just think about one set of numbers instead of two set of numbers. And it's also easier to just graph because we can just like draw a line. You could use graph paper. They give you graph paper for the Regents exam. That's totally fine. You can do that. So I'm just going to focus on these x coordinates and look for the correct answer that way because they're all different, right? So if I'm starting at -2 on the number line and I'm going up to 3, something like that. So this would be -1, this would be 0, this would be 1, this would be 2. And so I want 1 on the left and 4 on the right. So I want one space on the left and 4 on the right. 1, 2, 3, 4. There is my answer. -1. You can go ahead and do this with the y coordinates. You can plot the whole thing. I just find it easier to just kind of deal with the x coordinates and then makes it a lot easier for me. Hopefully you find that too. So 17 was 4. Oh, a spherical balloon is inflated with helium to a diameter of 1.7 feet. That's a pretty big balloon. 1 3/4 feet. It's a chunky balloon. All right, let's go ahead and draw a sphere. Whoops. Okay, so that's what our sphere is going to look like. And we want the diameter of this thing all the way across to be 1.7 feet. So what's the radius going to be? So the radius is going to be 0.85. How'd I get that? Well, 1.7 divided by 2. So that's going to be 0.85, 0.85. All right, so the volume is 4/3 pi r cubed. So we're just going to plug this radius into that formula. Volume is going to be 4/3 pi times 0.85 cubed. Alpha y equals 4/3 second. There we go. Pi times 0.85 to the third power. 2.5724 something, something, something. That's none of the answer choices. That is, again, shocking to me that they didn't do that. And it costs so that's cubic feet. So the volume is 2.57 cubic feet. And helium costs 0.80 cents per cubic foot. So I need to actually multiply this by 0.8 to figure out what it's going to cost me, right? So it's 2.57 of them. It's 2.57 cubic feet. Every cubic foot cost me 80 cents. So it's going to cost me $2.05, $2.06. Sorry. The one trick on here is if you mistakenly divided by 0.8, that would be this answer choice. So hopefully you didn't fall for that trick. So just think about it as like, hey, how many cubic feet do I have? I have 2.6 roughly, and it costs 80 cents for every cubic foot. So it's got to be a little bit more than, you know, anyway, 2.5. Okay. So if you ever see this setup for a right triangle question where they give you the left and the right, you can always find the height. We'll call it, I don't want to call it H, I'll call it, I don't know, I'll call it X. I know I'm looking for this. So right triangle ABD below, they should be blah, blah, blah. AC is 2.5. What is the length of BA? So I'm looking for BA. This is the thing I'm looking for. But I can find the height using that fun little formula, left over height equals height over right. So if I know that, and so it's going to be 2.5, we'll call that X, right? Equals X over 4.3. You can do this other ways, yes, for sure. And this is just like the easiest for me to remember. The other way to do it is like to draw those three separate right triangles and get everything aligned. That would take a little time. You can do it that way too. So 2.5 times 4.3 equals X times X, or X squared. 2.5 times 4.3 is 10.75 equals X squared. So if I take the square root of both sides, what am I left with? 10.75. Radical 10.75 is X. I'm just going to leave it as that for now. You're probably like, what are you doing? So be patient. We've got this. So I'm just going to focus now on this right triangle. And I'm going to sketch it down here. So we have this side is 2.5. And we have this side as radical 10.75. I'm looking for this side, call that y. Now I can just use Pythagorean theorem. A squared plus b squared equals c squared. Remember, c is always going to be the hypotenuse, so this would be my c. This would be my b. This would be my a. So it's going to be 2.5 squared plus radical 10.75 squared equals c squared. Well, 2.5 squared is 6.25. 10.7, radical 10.75 squared is just 10.75. You can plug it in your calculator. And that all equals c squared. So that's going to be 18 equals c squared. Take the square root of both sides. What is the square root of 18? 4.24. What did I do? I think I made a mistake. Oh, it's 17, not 18. Mental math. So why we have calculators, Mr. Fitz, you should use your calculator. So 6.25 plus 10.75 equals 17, and we want the square root of that, 4.1. There's your answer. All right, we got 10 minutes left and 5 questions. We can do it. I think some of them are pretty fast, actually, on the back end of this thing. Still no questions. Okay, good. Zoid has parallel sides ZO and DY. It's a trapezoid. So let's go ahead and sketch the trapezoid. You can make the sound effects when you sketch it if you want. ZOYD. Okay, those are the parallel sides. And the measure of angle Y is 73 degrees. And the measure of angle Z is 141 degrees. Okay. We need to find the measure of angle D. Just looking at my diagram, I know it's not an obtuse angle, right? So it can't be those. And odds are it's not going to be this one either, right? Because this one's already 73. And here's why. It's not an isosceles trapezoid. They didn't tell us it's isosceles. So if it were, that'd be true. But these two angles here have to be supplementary. And here's why. So if we think about parallel lines, right, cut by a transversal, then those two angles are what is known as same side interior angles, where remember when I said if the lines are parallel way back when, all of the acute angles are congruent, all the obtuse angles are congruent, and the acute obtuse angles equals 180. So that's why these two angles actually have to equal 180 degrees. So what's 180 minus 141? It's 39 degrees. Okay. Last one. Triangle is translated 5 units to the left and 2 units up to map onto PQR. Which statement is not always true? Well, they're definitely congruent. So triangle PQR is congruent to triangle, remember, stack your letters, ABC. This gives everything that lines up. Is A going to be congruent to angle Q? No. Oh, that's the one we're looking for, right? We want the one that's not true. Is RQ congruent to CB? Well, yeah, look at this. RQ, that's congruent to CB. So that one's out. PQR is congruent to ABC. That is definitely true. It's a rigid motion. Is A congruent to Q? No, it's got to be this one. This one is not true, and here's why. So if we actually like plotted like, so if this is B and it's going 5 units left, and 2 units up to where Q is going to be. So Q is here. What is this distance? Well, this is 2. This is 5. A squared plus B squared equals C squared. So 2 squared plus 5 squared equals C squared. That's 4 plus 25 equals C squared. 29 equals C squared. So this has to be radical 29. So this is true. So that's why it's wrong. it's number 2. But you can see, like, if you stack the letters, how easy it is to spot this one, right? So easy. Stack your letters. In the diagram below, congruent triangles PEN and PAL are drawn. Which rigid motion maps PEN onto PAL? Okay, well, let's take a look. Again, transformation question. Order of the points. This is going counterclockwise. PAL. Going the opposite way. This is clockwise. So I'm going to look for those words reflection again, because it has to be a reflection. There's no reflection there. There's a reflection here. So it's got to be either 1 or 2. It's definitely not this one or this one. A point reflection is actually the same thing as a rotation. So it's not this one, because a point reflection is a 180-degree rotation. So if you didn't know that, sorry, now you do. But the reason it's 2, if we think about this a little more, so a reflection over the angle bisector of EPA. So this is EPA. The angle bisector would be this thing. So yeah, if I reflect this over that line, yeah, it's going to be that one. So it's number 2. 2 left and 5 minutes. I can do it. 2.5 minutes each. Okay. A cone has a height of 8 and a volume of 75.4. What is the diameter of the cone? Okay, well, the volume of a cone is 1/3 pi r squared h. They told me the volume, so I'm going to go ahead and plug that in. And they told me the height. So I'm going to plug that in and solve for r. Okay, so what I'm going to do is I'm just going to go ahead and simplify the right-hand side of this equation, because we have 3 numbers over here, right? We have 1/3 pi and 8. Yeah, so let's just go ahead and multiply those things together. So second 1/3 times pi times 8. So it's going to be 8.377 something, 8.38. So 75.4 equals 8.38 r squared. All right, well, now I just need to divide both sides by that 8.38, right? And actually, I'm going to just go ahead and in my calculator, divide by this thing. So I don't even have to round it. So r squared is about equal to 9. But what's our r? Well, we have to take the square root of both sides. So if I take the square root of that, it's about equal to 3, right? There's my answer, right? Woohoo! No, they're trying to trick you. It's the diameter. You want 6. Be careful. They always do that too at the end, because like they know you're gonna be more tired and like make more mistakes. So be careful, read the questions carefully. This last one is only gonna take me a minute, literally, just because a line represented by the equation of 5x minus 2y is transformed by a dilation centered at 2, 0. If you ever see something that's not centered at the origin and it's a line dilation, what you should do is just go ahead and plug in the coordinates into the equation, and see if that point is on the line. So that's what I'm going to do. 5 times 2, that's my x, that's my y. 5, so I'm going to plug in 2 here and 0 here. 5 times 2 minus 2 times 0. Does that equal 10? Well, 5 times 2 is 10. Negative 2 times 0 is 0. Yeah. So this point is on the line. So if the center of dilation is actually on the line, I don't know what this equation looks like. I don't know. The slope is going to be positive, yeah. So say it looks, I don't know, something like this, right? And the center of dilation is somewhere here. So what's going to happen is all of these points are just going to stretch out along the line. So like this point would go to here, and then this point would go to here. And so everything's going to kind of stretch out this way, and the line is going to be the same line. So it's just going to be the original line. So if the center of dilation is ever on the line, it's going to be the same line. There you go. That's the answer. And I finished at exactly 4 o'clock. How about that? All right. Any questions before we depart? No? Sure. This is our very last multiple choice review. Tomorrow is our very, very last review. So, and I would say, those of us that, well, I guess we all took this Regents exam, right? That is where will the June test be similar to what do you mean the retake? Oh, well, to the August test? Well, probably. I would say they might shuffle around some of the short answer questions. I don't think they'll give you the same type of proof. I think they'll probably make the 6-point question a coordinate proof. And then the 4-point question will be like a triangle proof. This is just a total guess. I have no idea. Um, um, just by intuition, I think. Other than that, I would say the multiple choice will be very similar. Yeah. Um, I don't know if they're not going to be the exact same questions, but yeah, they should be similar. Um, and then the short answer questions, please, you should attend tomorrow. You should review them tonight. Try all of the questions. I posted them and the solution guide on, I haven't posted the solution guide yet. I will post the solution guide after this. Check your answers and come with questions because this is where we all struggled on the June Regents exam was the short answer. So yeah, I would, if you're going to spend any amount of time, that's the time you should do right now. Like right after this, I would start those questions. Any other questions about the region or anything? Okie dokie. All right. Thanks for attending. I will see you all tomorrow. And I'll post these video.